Hey, don't forget my math industry, and we are going to take a look at inverse functions. So in the past few videos, we have been taking a lot about compositions and also trying to find if there are two functions on a piece of paper, or if there are two functions on a graph, then would they get to x and would they be inverse of each other? Well, there is one little issue and one little problem about this kind of video. Instead, this video only has one function, so what we have to do is try to find the inverse of that function. So we are able to get two functions, but they are inverse of each other. So let's get started on what this problem does. So this problem has an f of x equals negative 4x plus 1. The first thing we gotta do is try to understand what the inverse function is. You might think it's going to be positive 4x minus 1. Well, that is not actually what we're supposed to be doing. What we try to do is see what happens. So, in the last videos, we have been taking a look at this picture right here, or this table right over here. When you have f of x equals 2x, you have this. But when you try to do an inverse function, which mathematically is that, it looks like whatever you put in for x is going to be in for y, and whatever you put in for y is going to be x. Like negative 4 and negative 8, you switch them around. If you go to negative 15, negative 3, the inverse, you switch them around. So if we understand how to do that, the first step should be very easy, saying that f of x is going to equal y. What we're trying to do is try to kind of put everything on the same level and the same communication level for like every mathematician, because when you usually do a ratio table, the y is usually sometimes referred as the f of x, because that's the result of a function. Whatever you put in for x will result in the f of x. So that's going to be our y. So y is going to equal negative 4x plus 1. But we're not done yet. We still got to understand what just happened. Remember how we said that whatever you put in for x and y is reversed in the inverse function? Well, we have to do that to this same thing too. So x and y will be able to switch their places. So x is going to equal negative 4y plus 1. We have to get that y alone, so it can be happy again. So subtract by 1, x minus 1 equals negative 4y. Divide by negative 4, divide this by negative 4, and y is equal to x minus 1 divided by negative 4. But hang on, why are we using the y value as our answer? What we wanted to do is use the x value and also add a function. So what we gotta do is turn that y back, and all you gotta do is write our answer out. The function of negative 1 of x, negative 1 represents that there is an inverse function of the same letter, not meaning that there is an exponential rule in it. And negative 1 is supposed to help you realize that this is an inverse function of the same letter. It's gonna equal x minus 1 divided by negative 4. Having something that looks like this, where it's x minus a number divided by a number, is common when it comes to calculating an inverse function. If you try to put this and this together, and you would do the composition of functions, then they would both equal to x, which means they are inverse. It's a way to double check your work. Let's try to do one more example. So for this one, we have h of x equals 2x divided by 3 minus 5. At first, we change this into a y. Then that equals 2x divided by 3 minus 5. Then we have to change the y and the x around. So x equals 2y divided by 3 minus 5. Then solve algebraically. X plus 5 is going to equal 2y divided by 3 times by 3 multiplied by 3, 3x plus 5 is going to equal 2y divided by 3. Wait, we got rid of that 3. And that number is supposed to be a 15 because the 3x plus 15 is kind of connected. So we have to divide everything by 2 and divide this by 2. And y is going to be equal to 3x plus 5, 15, divide that by 2. And when you do that, you are going to have h of negative 1x is going to be equal to 3x plus 15 divided by 2. So that is going to be the inverse function for that one. And that also explains how and why these are inverse of each other and why the x and y's are opposites of each other. If you put it on a graph, it's not exactly the same kind of slope or whatever it is, but we do know that they're going to be inverse of each other. Not always the same kind of slope. We can't guarantee that. So I hope this video has helped you understand inverse functions. Thank you for watching How Penguin Likes the Math Industry. Like and subscribe.